Hello, everyone. Good to see everyone. First off, want to make sure and do a test. I see a lot of people from everywhere. If you can see me and hear me really well, please chat in where you're tuning in from. It could be your city or your living room. Feel free to chat whatever you can in there. Just want to do a little test. Also, I just want to shout out everyone while waiting for this program that has already donated. 2 thumbs up, high fives all around. Thank you so much. We really, really appreciate it. How are we doing on sound? We're good? All right. Let's get this going. Again, I wanted to thank everyone. New Mexico, awesome. Erica, I'm your #1 fan. Hey, look at elementary coming in. All right, this is great. Hello, my name is Eric. I'm your membership manager here at Chabot Space and Science Center, and welcome to our rendition of Mars Madness Variety Show, or how I've been liking to say is our Mars Madness Mishmash, here live at Going the Distance. You can see I've got Mars in the background. We have a rover behind me, and our shrimp rover back in the case over there. We're thrilled to be bringing you another exciting and fun, awesome program live from in Chabot to your homes. We really appreciate everyone's time and support during our temporary closures. And just want to shout out our members, donors, partners, volunteers, everyone that's been leaning in to help our programming continue during this time. We are engaging and developing stuff to feed your curiosity and expand your universe with new online activities, events like this, videos and recordings, and we're really thrilled to share so much more. So, tonight's program, we are celebrating the NASA launch of the Mars 2020 Perseverance rover. This is a really, really exciting time. We're tuning in tonight to show some beautiful Mars images from Chabot's own telescope, taken from our telescopes and our domes here. Tonight we're going to show you how to make your own Mars rovers, so a little fun little STEM activity that you can do at home. Another cool foodie recipe that we're calling Mars Rock Drink Bombs, recorded from our very own Lisa Hoover. And also meet one of our astronomers' own mini rovers that's behind me right here that you can see over my shoulder, called Curiosity Junior, or what we like to say as CJ. We will even throw a little bit of some Mars trivia. Props to Ben Burris for leaning in and giving us some trivia questions. And we're going to have a Q&A and a dance party, of course. All right. So we are going to start it off with some trivia, because we do love trivia here at Chabot. All right. Question number 1. Get ready to chat in your answers. Mars is called the red planet for its orange-red color. Why is it red? Mars is rusty? Or 2, Mars is covered with seas of molten lava which glows red. 3, being farther from the sun than Earth, all of Mars' vegetation is reddish to absorb more sunlight. Or 4, the water-related mineral hematite is abundant in Martian soil. Chat in your answers. Oh, look at you, smarty pantses. I love it. And the answer is number 1. The red comes from iron oxide in Mars soil, and it's the rust. All right, we're going to go for question number 2. Get ready. See some stuff coming in from question number 1 still. Okay, question number 2. Get ready. The first spacecraft ever to reach Mars was number 1, Viking in 1976, Number 2, the Russian Mars 2 in 1971. Number 3, Mariner 4 in 1965. Or number 4, Mars Odyssey in 2001. Someone give me some trivia music. If you're out there, we're looking for our own Chabot themed trivia sound. Yep, everyone's chiming in. Are you ready for the answer? The answer is number 3, Mariner 4. Flew past Mars in 1965 and was only the second spacecraft to reach another planet. Mariner 2 flew by Venus in 1962. So that means 1960s technology has reached this planet. So I'm pretty confident with our new technology that we will be getting to Mars and seeing a lot more of Mars, and I'm really excited about it. Some other things about Mars landing. There have been 8 successful U.S. Mars landings. Viking 1 and Viking 2, both in 1976. There was Pathfinder in 1997. The Spirit and Opportunity, both in 2004. Yes, that was a trick question, Mark. Not really, but. Phoenix in 2008, Curiosity in 2012, and Insight in 2018. To share more about the 50 years of Mars exploration, check out this video, and I'll see you right after the video.
Hey, there we go. There she goes. Yeah, that's data.
There is some sort of a hacker to the data, and we have now full confidence that this does indeed correspond to a photograph of Mars.
Based on your preliminary analysis of this data, can you describe what you see on Mars?
Yes, it's there.
Standing back for touchdown.
By the extraordinary men and women of NASA in our Jet Propulsion Laboratory. Right now, the wheels of curiosity have begun to blaze the trail for human footprints on Mars.
Well, today on Mars, history was made on Earth. The successful landing of Curiosity will stand as an American point of pride far into the future.
I just wanted to call and say congratulations to the entire Mars Science Laboratory team and really all of JPL. You guys should be remarkably proud.
Wow, who doesn't love inspirational music set to space? That was super inspiring. You know what's even more inspiring is seeing how many people are on here and making it rain. Thank you all for the donations in these first 10 minutes of the programming. Super, super stoked on that. I'm super stoked on all of our space exploration. Real quick, can I get a thumbs up? You know, I love the design of all these different spacecraft and all the different tools, and then seeing everyone's fashion of the time. But thumbs up, give me a thumbs up if anyone out there remembers dot matrix paper that was like seen in the beginning of this video. Can I get any thumbs up for dot matrix paper? Dot matrix. Awesome. So we're all excited about the 2020 mission. Here's another quick video from NASA on its mission overview of the Mars 2020 mission. Check it out.
NASA's next Mars rover is in development and has an ambitious mission. Decades of Mars research from previous spacecraft have shown the planet not only had water in the ancient past, but had environments that could have supported life.
Mars is our neighboring planet and in many ways the most similar to us, and certainly in its history. And the question whether ancient life was there is still the question that keeps us up at night.
Mars 2020 has two new objectives: to specifically seek the signs of life and then sample materials and prepare a cache that could be returned to Earth by a future mission.
Mars 2020 is really the essential first part of a sample return mission. So it actually looks at the environment of these samples and then collects them and stores them. Afterwards, we will of course go and bring these samples back. So Mars 2020 is the first half of a return trip.
The Mars 2020 mission, to the maximum extent possible, follows the Mars Science Laboratory Curiosity mission. We're going to use very similar rocket, very similar cruise stage, very similar entry, descent, and landing. And the rover, when you step back, will look almost identical.
Not only were a lot of designs already developed for the most part, but we're also using a lot of spare hardware that we had from MSL or Curiosity for Mars 2020. If you know where to look on Lab, you can walk around and see a lot of the EDL hardware and the cruise stage hardware that's already been built.
And this is really important for understanding why this mission makes sense. We have to do relatively little in the way of new development. And this saves money, it saves risk, it saves time. It's the right way to pursue this kind of mission.
Mars 2020 also features new technologies for entry, descent, and landing, allowing it to target a smaller landing zone and even divert from known risks in the area.
It means that we can both go to places that are maybe more interesting to the scientists because we're able to handle places with more hazards, as well as land closer to the things that they're interested in off the bat. So we get to the science that they care about and more quickly.
The three key sites that we are considering right now share one thing in common. They are all environments that might have been habitable in the very distant past. One of them is the floor of an ancient lake. Another is a hot spring. and the third one is a site where hot water interacted with rocks in the shallow subsurface. We have instruments on board which are expressly designed to seek evidence of ancient life, what we call biosignatures, and we have the capability to prepare samples, drill them out of a rock, seal them in a tube so that a future mission could go and bring them up. We call that caching.
So it is a first of a new type of mission, which is to bring samples back to the best labs we have, which are here on Earth. Mars 2020 is a pivotal mission in our search for life that could finally answer the age-old question, are we alone?
Wow, that was awesome. I really love the part where they're really pushing recycle and reusing. I would love to know out there, if you can chat really quickly, the last thing you repurposed or reused and the thing you reused it for. I'll give you a couple seconds to chat in answers. I really am curious to hear what you're reusing and reusing it for. Sorry, I'm waiting for the lag time so I can see answers. But until then, so, naming these things is very interesting to me. And, the launch of Perseverance for Mars 2020 was named by a kid named Alex Mather, which brings me to a memory. Cheryl, if you're out there, my old boss, invited me into the office one day while she was sitting there, and she looked really perplexed. And, I thought we were about to talk about something super serious. Water bottles, really great to reuse. Shopping bags, too. She called me in, and, I thought we were about to get into some heavy stuff, and she's like showing me a list of names, and she was like, what do you think about these names? I'm like, what are these for? And I thought we're renaming something at the center here. And she was like, well, she was invited on this committee to help choose a name for what ended up being Alex's name, or Alex's submitted name for Perseverance. Anyway, sorry about that side story. But anyway, here's, we're really stoked for Alex, and it must be such a proud moment for his parents and everybody just to get something named that's going in space. So check out this really cool video of Alex and about naming the rover. Here you go.
NASA's newest rover is gearing up for its journey to Mars. We've been building the rover and getting it ready for launch, and kids across the country have played a big part too. We asked for your help to name the rover, and you answered the call. 28,000 kids sent in their essays with their best ideas. 4,700 judges helped narrow them down, and the world weighed in on their favorites too. Thanks to you, we now have a name. Perseverance.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans. We're always curious and seek opportunity. We have the spirit and insight to explore the moon, Mars, and beyond. But if rovers are to be the qualities of us as a race, we missed the most important thing: perseverance. We as humans evolved as creatures who could learn to adapt to any situation, no matter how harsh. We are a species of explorers, and we will meet many setbacks on the way to Mars. However, we can persevere. We, not as a nation, but as humans, will not give up. The human race will always persevere into the future.
That name is going to live on Mars forever because it's going to be etched on the rover's robotic arm right there. The rover's mission is to seek signs of ancient life, collect rock samples for future retrieval, and to pave the way for human exploration of Mars someday. It's going to be a very exciting mission, and perseverance is going to be crucial to it all.
Thanks to all who helped us get here. Be sure to follow the journey of Perseverance as it explores the red planet.
Hey, how about that? Alex Mather. Can we get some claps out there for him? 2 snaps and a clap. Alex, proud of you. Also, if you want to inspire others like Alex, that, you know, the next Alex, the next big maker, the next big scientist, don't forget to donate and press that button right below your screen. You know, speaking of things to do and creating and making, no Chabot event is lacking of hands-on activity. We're really excited to put on more stuff like this. Enjoy this recording of making a Mars rover from things at home. You know, try it out at home this weekend, and don't forget to, you know, post a picture on it and tag us on it, hashtag Chabot Space. We would love to see everything you're making at home, everything you're just diving into and learning about. We definitely would love to see it. So don't forget to tag us on any pictures. We really would love to see it. So check out this video on how to make a rover at home out of stuff. Enjoy.
This is Sam Bell, science journalist at Chabot Space and Science Center, and I am here to bring your attention to a pretty disturbing fact. Mars is solely populated by robots. Pretty weird, huh? What are they doing on there? Are robots trying to take over Mars? How do they even get their names? What are rovers anyways? Should I be afraid of rovers? These are just a few of the many questions that I have about the Martian robotic takeover, and I am here to do some good old-fashioned investigative journalism to find my answers. What are rovers, and why do we keep sending them to Mars? The answer is kind of simple. Earth and Mars have a lot of similarities. They both have polar ice caps, clouds in its atmosphere, volcanoes, canyons, and even seasonal weather. There's a lot of evidence that water used to be in abundance on Mars, and we are even seeing indications that there is water on Mars today. Now all that leads to one big question. Is there life on Mars? Not this type of life. I'm talking more about microorganisms like this, the types of organisms that you can't see without specialized equipment. What we have learned about life on Earth is that wherever we have found water, we have found life. So if we are able to find water on Mars, we are hoping, fingers crossed, that we can find life. So we send rovers to Mars in order to search for these signs of life. What I'm saying is that rovers don't seem all that bad. In fact, they help us do some very important scientific research that could lead us to finding life on another planet. So, more space friends, please. Now, I wanted to learn more about the components of rovers, so I called upon our Chabot resident expert in rover education, Professor Ellie Morris. Hey, Ellie.
Hey, Sam.
I've been learning a lot about rovers, and I want to learn about the different components of a rover. Now, it's my understanding that you're going to walk me through how to make my own rover, because I want to know what NASA is thinking when they are building a robot that's going to go all the way to Mars.
That's right, Sam. Building a rover might seem really complicated, but once we break it down, it's actually pretty simple. All rovers have the same basic parts, so once we understand what those parts are, recreating one at home with our own objects is pretty easy. All rovers have a body, which holds it together, a brain.
A brain? Like our brain?
Yeah, just like our brain. The brain of the rover holds all the computers, which help with collecting data and communicating back with planet Earth. All rovers have wheels, which can help it move around, and arms, which can either hold tools or cameras to help with some of that science and that data that these rovers are collecting.
Wow! So what would I need to build a rover at home?
Yeah, great question. Now that we understand how a rover works, there's a lot of different materials that you can use at home to build your own. Cardboard boxes make great bodies for your rover. Either one like this or even one from your favorite snack would work too. Anything that will roll, like a tin can or even a toilet paper roll, make great wheels. And then for arms, you can use popsicle sticks, toothpicks, straws, anything long and skinny will work really well for that. So make sure you search your recycling and check your items before you're throwing them away, because some of them might be great materials to use to help you build a rover. Oh, and don't forget to give your rover a name too after you've built it. Back to you, Sam.
Thanks, Ellie. To learn more about making a rover, click on the link below. One of the things that has always piqued my curiosity is, how do rovers get their names? Who names these little planet explorers? In recent news, NASA announced what the name of its new rover was going to be. This was on March 8th. Now, NASA had put out a contest over the past 6 months asking students to name their new rover. After receiving over 28,000 entries, NASA announced that 7th grader Alex Mather won the contest, naming the new rover Perseverance. Perseverance is currently in Florida awaiting launch, which is due to take off in July of this year, and we have our fingers crossed that it will make its launch window. Click on the link below to learn more about how to make your own rover at home, and please feel free to add any questions you may have about rovers in the comments. This is Sam Bell here to embrace our rover friends on Mars and keeping my hope up that we may find life on another planet. Over and out.
Wow. Thanks for tuning in on that. We really miss our colleagues. Our team definitely has been reduced, but our education team right now is working tirelessly, putting together activities, more recordings, workshops. We're posting them to our website, and you can check it out really easy and do all these really fun activities from home with stuff at home. Check out chabotspace.org/education/learning launchpad, and just chabotspace.org just to find out more. You can also, on the website, click on Join and Give and figure out how to become a member, or you can click that donate button. Ding, 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 ding. Check out our members website. We have a members only site that has a lot more live workshops recorded. You have access to live workshops at home on Zoom with Q&A with a bunch of different other people. We are still partnered with the Town Kitchen Cafe. They have a pantry and they're offering pantry goods, and Chabot members get a discount over there. And we will definitely have exclusive member preview days once we reopen. So check it out. There's lots to come, and we're excited to share much, much more. So chabotspace.org and learn more, or click that donate button. Let's do trivia. Question number 3. The names of Mars' 2 tiny moons, Phobos and Deimos, mean 1, small and smaller, 2, fear and terror, 3, potato and pickle, or 4, named for the discoverer Phoebe Diamantopoulos. Chat in your answers. Oh, look at this. They're coming in. Also, thanks for the shout out. I saw someone commented, I love being a host for these things, so thank you. Yes, and the answer is number 2. Fear and terror are the mythological helpers of of Mars, the god of war. Question number 4. Astrobiologists, scientists who search for extraterrestrial microbes, are interested in Mars because 1, it's the planet in our solar system most like Earth. 2, Mars probably had seas of liquid water in the past. 3, robotic landers have detected methane on Mars. Or 4, all of the above. Yes! The answer is 4, all of the above. I do love me a good all of the above answer. I gotta say, I love those. With all these launches and the talk about Mars, do you ever wonder what it will take to get to Mars, really? I know a lot of us do, and I know there's a lot of stuff out there. So we kind of narrowed it down for you. We found some really great stuff. Check out these videos of how to get to Mars.
How do you get to Mars? If you want to send a spacecraft all the way to Mars, first you'll need a fast rocket to escape the pull of Earth's gravity. The heavier your spacecraft, the more powerful your rocket needs to be to lift off. Next, make sure you launch at the right time. Mars and Earth orbit the Sun at different speeds and distances. Sometimes they're really far apart, and other times they come closer together. About every 2 years, the two planets are in perfect positions to get to Mars with the least amount of rocket fuel. That's important. The total trip is over 300 million miles. Finally, make sure your aim is right. You can't shoot for where Mars is at launch time. You have to aim for where it will be when you get there. It's a lot like how a quarterback passes a football. Also, you may need a few thrusts to correct your direction along the way so you don't miss Mars. If all goes well, you'll get to the red planet in about 7 or 8 months. Then, if you actually want to land on Mars, well, that's a whole other challenge.
Wow. So all of this preciseness, requires just so much math and science. It's really, really quite amazing on how exact everything needs to be. So once we're up there and cruising towards this planet, how do we land? So check out this video on explaining how we actually will try and land on Mars.
How do you land on Mars? Very carefully. Your spacecraft hurtles toward the planet at thousands of miles per hour, so you'll have to hit the brakes in a hurry. First, your capsule needs a heat shield. It protects the spacecraft inside from the heat and friction of entry into the atmosphere. Friction slows you down over 90%, but not enough to land safely. Use a parachute to slow down even more. Still, falling at over 100 miles per hour, you need the right system to land safely. Here are some options. With a small to mid-size rover, use a cushion of airbags along with retro rockets. Impact at 30 miles an hour and bounce to a stop. With a large lander, use retro rockets and landing legs to touch down going about 6 miles an hour. Or with a large heavy rover, use a big jetpack to slow down to under 2 miles an hour. Then gently lower it on cables to land on its wheels. Any way you do it, you'll need skill and hard work. There's nothing easy about landing on Mars.
Whoa, you know what this reminds me of? Has anybody been, or do you remember going the distance and doing the impact challenge and trying to figure out in our design zone here at the center of how to land something and not break, or at least just lessen the impact? Anyway, I really miss seeing people in here designing things inside the center. But we've now come to one of my favorite parts of the night that I've really been enjoying. Does anybody out there remember Sprockets from Saturday Night Live with Mike Myers as Dita? In the Sprockets fashion, this is the time in Chabot when we dance. Did you dance it out? I did. You know I did. Hey, DJ B1, we miss you. We got lots of love for you. Thanks for putting together yet another awesome video for us. Yes, everyone, sprockets, right? Am I right? DJ B1 is a multidisciplinary artist across many mediums, dissolving boundaries between familiar and the unknown. DJ sets can be described as energetic, feel-good, original, and fun, blending all styles of the best music in unique ways to get you moving always upwards. Cindy, I saw that you like this music. Go check out more at www.b1music.org and yeah, support our local DJ. Another fun thing is I love doing food stuff. I am a foodie at heart. I know a lot of people are foodies at heart. I know coming to Chabot, everyone has such an awesome DIY community up here. And I mean, to be honest, living in the Bay Area, the access to just food, the potlucks, man, remember potlucks when you could have a potluck? I'm excited to have that because everyone's learning so many awesome things to do now in the kitchen. Sourdough this, sourdough that, bake this, bake that. I think I can't wait to see it. Anyway, also what I love is our Lisa Hoover that puts together awesome recipes, science-based recipes. Yet another episode of making a drink. We have Lisa's Mars Drink Bomb. Let me have some hearts out there if you tried any of Lisa's other drinks or other recipes that we've posted. So check this out, and I'll see you in 5 minutes.
Hi, I'm Lisa Hoover, Programs Manager at Chabot Space and Science Center, coming to you from the Cosmic Kitchen here at Chabot Space and Science Center. And today we're making drink bombs. That's right, drink bombs, not bath bombs, but it's a similar concept. Are you ready? Here's what you'll need. Here's tonight's recipe. 1 tablespoon of baking soda, 2 tablespoons of citric acid, 1/4 cup of powdered sugar or acacia, 2 tablespoons of cornstarch, 1/2 teaspoon of baking powder, 1.5 teaspoons of flavored food coloring, or you can do that separately if you don't have a food coloring that has flavor or flavor that doesn't have food coloring, and 2 single servings flavored drink packets. Mix all of the dry ingredients except the citric acid. We're going to save that for last because we don't want a reaction too soon. You want to slowly incorporate the coloring so that you don't lose all of your reaction all at once. And it takes a little while. You want to mix until you get a nice granular texture that's not wet. Now let's add the citric acid and mix thoroughly. And let's begin to add a little bit of moisture. I recommend a spray bottle so we can control that reaction as much as possible. The mixture should still be fairly dry, but when you squeeze it, it should form together in clumps, and that's how you'll know it's ready. Citric acid is a weak acid that naturally occurs in all citrus fruits like lemons, limes, grapefruits, oranges, and a few more. It's what gives those fruits that sour taste. To form the drink balm, just spoon together, hold it firm, and then set it out to dry. The mixture is really sensitive to changes in moisture, so it's really important if you're in a fairly humid room like the kitchen or it's a muggy day that you cover the drink balm so that they can dry overnight without reacting to the air.
All right, it's time to enjoy this drink balm. I'm going to go ahead and drop it in a glass of salsa water here. Bombs away.
Here are a few more examples of some of my other drink bombs. You can play with the experiment and play with the ratio of materials to see if you can get the fizziest action. You can also drop it in tonic water and use a black light if you'd like your drink to glow. The possibilities are endless. Imagine adding pop rocks to your drink for an extra sparkle.
Signing off from the Cosmic Kitchen. Good night.
Hey, welcome back. So, I don't know about you, but watching that video, all I kept on thinking of is like Aperol Spritz? Whoa. Campari soda? Yes. You know, no judgment. If anyone out there tries to make a cocktail out of this recipe, send it over. Tag us, you know, hashtag Chabot Space. I'd love to see those drinks come in. If you like that video and other videos like that, there's more to come. If you remember and you saw the root beer making from episode from last week that we had, that'll be up on the site soon. So just hang tight. All that'll be on. The donations are still coming in. Thank you, everybody, for that. That's really awesome. So shout out to that. Jamie, hold on a second. We're getting to the rover. The rover's back there. Also, Gerald is asking if you're past your bedtime. Thanks for tuning in, Jamie. I know you're coming out from afar. Thanks for all your hard work on the ground level, on the front line, for everybody out where you're at. Also, shout out to everyone that's on the front line right now, helping out and everything. I really appreciate it, everything. If you want to see more of these fun recorded workshops and recipes and activities, don't forget to go to chabotspace.org. Speaking of rovers, you know, you can see this rover on my left, and then behind that our shrimp rover. You know, give me a thumbs up if you've driven the shrimp rover in going to distance, and give me a heart if you found Matt Damon while driving the shrimp rover that good old Ben Burr has put in there for a couple months. If you got to see that, I'd love it. You know, I'm really, that was just like awesome. As a kid, I loved building remote control cars. Now with with drones. I can see that the new generation of remote control is just like, it's a whole new level, right? So the appeal, though, is just always been there of being able to control something from afar, you know, being over here and controlling something over there and watching what it does. So can you imagine the excitement of being able to create and build a rover or spacecraft that's remote control and controlling it from Earth and then doing science experiments from thousands of miles away? Like, whoa, super awesome. Anyway, check out this awesome video of the rover and testing the rover from NASA. Check it out. Wow, seeing that is really getting me excited. For all you kids out there, I hope this is really inspiring you to just learn more and be able to create things that will do amazing things. I have faith that you all, the next generation, will be making some really great things. So once it's made, once it's up there, how are they going to drive it? So check out this really quick video, and then we'll see what's behind me in just a moment. So check out this, and we'll get ready to see the rover behind me.
How do rovers drive on Mars? First of all, there's no joystick for driving a Mars rover. Before a rover hits the road, engineers send computer commands overnight, telling it where to go the next day. Depending on how tricky the terrain is, rover drivers have two options. They can send a string of specific commands like drive forward 5 meters, then turn right 90 degrees. The rover turns its wheels enough times to add up to 5 meters, and then turns in place. Or if it looks safe, they can let the rover think on its own. They write commands like, see that rock over there? Find your way there safely. Then, using two cameras like human eyes, the rover gets a 3D view of hazards such as large rocks and steep slopes. After mapping the danger zones, it plots the safest route to avoid them. Either way, did the rover complete its drive as planned? Engineers double-check when the rover sends back a postcard of its new spot on Mars.
Whoa, that's crazy, right? Big props to our exhibits team who designed our shrimp rover to, have the same interaction to control. All right, so behind me over here is, Curiosity Junior. So, I think putting things together and making models has always been, a big hobby of mine, just building things. Gerald from, telescopes and all of our online stuff right now, our favorite astronomer here. But did you know that Gerald's wife actually built this Curiosity Junior that we like to call CJ? So I'm going to pass it over to Gerald, and he's going to talk about this awesome model and remote control vehicle. Take it away.
Let's turn the camera. Okay, that's good, right? Okay, so as Eric says, this is CJ. CJ stands for Curiosity Junior, and it was designed and built by my wife, Laura McKeegan. On Mars right now, there is a rover called Curiosity, and it's a big rover. It's the size of a car, and it weighs over 2,000 pounds. CJ, quarter scale working model of the Curiosity rover. So everything is 1/4 the size of the real one on Mars. My wife was kind of roaming around on the internet. She saw a website about a guy who started to make one of these, but he didn't get very far. And she decided she was going to go for it. It just happened to be about the time that she got access to really good 3D. So she started doing the research, looking up specifications, photos, images, actually measuring things on the screen in order to figure out all the dimensions, all the specifications for the Curiosity rover. So she could then design all of the same parts for a 3D printer. So she designed it. I'll show you right now to thing. So Jessica, if you can go ahead and show the video. CJ includes things like a tool arm on the front end of it that can be extended just like that's a tool package at the end of it, which has all kinds of different tools like a drill, a Hammond camera, a brush, or X-ray spectrometer. On the real rover, it can extend that arm and drill into rocks and take samples and so forth. And also take nice close-up photos to do analysis of the surface. One of the cool things about CJ is that it reproduces the so-called rocker boogie wheel system on Curiosity. This allows Curiosity to go over rocks and terrain, rough terrain, and remain stable as it goes over them. One of the cool things also is it can traverse very rough terrain, go up and down rough terrain, and actually stay pretty much level while it does that. All 6 wheels are independently driven, and the 4 corner wheels can actually move independently so that it can do donuts on Mars. Okay, so there's a lot of details on the rover, including things like the antennae. This is the UHF antenna, the Omni antenna, and then the high gain antenna. These are all for communications. The rover also has a mast, which has cameras, has the ChemCam X-ray analyzer, and it also has a copy of the RTG, the power source on the rover. But CJ's power source is just batteries, and there's a control panel on the back end of the rover. The electronics that you see were designed and built also by my wife, and it allows the rover to be remotely controlled via an internal website, and it also lets you see what CJ's camera is seeing. Now, CJ was originally built for a series of space-themed demonstration programs hosted by the Contra Costa County Libraries. Kids really enjoyed seeing it. They also liked controlling it and seeing themselves on CJ's camera. Some of these library events had some interesting characters, especially a lot of characters from Star Wars, including, of course, the big guy himself. Now, just for fun, last Halloween, we set CJ up to give candy out to kids who came to the door. So that's the CJ rover. And one other thing I want to do here, Eric, if we can go ahead and turn the camera back. And what I want you to do is stand in front of CJ. Just hang on with me here. All right, go ahead and stand right here in front of CJ. And I'm going to show everybody what CJ is seeing. So there's Eric standing in front of CJ. This is really a lot of fun when you get kids around the rover and they get to see themselves on the screen as the rover moves around. So that's CJ, Curiosity Junior, a 1/4 scale model of the Curiosity rover on Mars. Back to you, Eric.
Haha, yes, I was just going to ask, did anybody notice a little character on top of CJ? We have a couple questions. Number one is, what electronics are used to power CJ? Did you already go over that?
Yes, it's
okay.
Battery control.
And then, what's your wife's background?
Well, when she was in the Army, she was certified to repair small arms. She's always been very technical. She repaired typewriters in her early career, and she is now the IT manager for the Contra Costa County Library System.
Awesome. Well, thanks for that. Yes, and, I think the inspiring part for me is this, is seeing something like this being made, and I think, that's kind of where we're at with Chabot and our mission. So, helping support us this time really helps us to inspire our youth and just other people for STEM education and figuring out how to inspire people to make really great things. So yeah, you can either donate now on that button. Thanks for, they're trickling in still throughout the night. Really appreciate that. Or chabotspace.org, join and give. If you're a member, you can definitely join or renew. And also, tag us on any stuff you're really doing. I really want to see more pictures out there of what you're really doing and learning. So we're getting close to the end. We're going to wrap it up with our trivia. We have our last two questions, and we have another thing coming after that. So kiddos at home, if you have to go to bed, thanks for hanging in there. But everyone else, we still have just a few more things to go. So hang tight. All right, so our next question is, standing on Mars' surface, you would weigh 1, the same as you do on Earth because your body mass is constant to no matter what planet you stand on. 2, about 1/3 your Earth weight. 3, about 2/3 your Earth weight. Or 4, 21% heavier than your Earth weight. Put them in the chat. Are you seeing anything in it? Okay. Yeah? All right, there they come. All right. Nice, 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 nice. And the answer is, here it comes, number 2, 38%, or about 1/3 of your Earth weight. Good job, everyone. Hope you're all learning stuff. I know I am. Question number 6. This is the last question of the night, so make it big, make it big. Here we go. A typical voyage from Earth to Mars takes 3 days, number 2, 9 weeks, number 3, 7 months, or number 4, 2 years. Type it in. No, I can't tell if these are the ones. And the answer is 3. Though Earth and Mars only get close enough to each other for us to easily send a spacecraft there every 2 years, the actual time it takes to get there with our current technology is about 7 months. Whoa. That's a long time to be in a little spacecraft. Again, I want to invite Gerald back. He's going to show us some really cool astrophotography. I know there's a lot of interest in that. So without further ado, Gerald, take it away for some Mars astrophotography.
Okay, so we're going to wait for Jessica to get things set up here. And we got several pictures here. So we're going to start out with a couple of pictures taken by Conrad Jung using Chabot's telescopes. There we go. There's the first image. This is Mars. Now, it's not a very clear image. When we are observing from here at Chabot, Mars is very small and it's pretty far away. And so it's hard to get a really clear image, especially if we've got any kind of wind or turbulence in the air or anything like that. We tend to get pretty fuzzy images, but still you can see a lot of detail. If you notice that little white patch on the top, that's one of the Mars polar caps. So this was taken, I believe, in, I think, 2007. Now we've got another image here taken in 2005. It's actually a series of images. Just a second here. We got to go. All right, now we got it. Okay, so these are 3 images taken over a period of time in 2005. Mars gets close to Earth about every 2 years, actually every 2 years and 2 months. And as it gets closer, it appears larger and larger. Now, contrary to what you may have seen in some emails back a few years ago, Mars never looks as big as the moon. There was an email hoax that went around for several years saying that Mars, when it was closest to the Earth, was going to look as big as the moon. You don't want that. If it's that close and that big, we're all in trouble. But these images here give you an idea of how it gets larger and larger as it gets closer and closer over a period of a couple of months. Okay, the next image is actually not taken by Chabot's telescope. This was taken by an amateur astronomer named Damien Peach. And Damien Peach lives in England, about 30 miles southeast of London. And he specializes in taking planetary imagery using an amateur telescope. In fact, his telescope is identical to the amateur telescope that I have in my backyard, but he's way better at doing astrophotography than I am. So what Damien did is took thousands and thousands of images of Mars over a long period of time and pieced together the best of them to produce a image of Mars rotating, doing one complete rotation around its axis. And again, you can see the white polar ice cap. As it rotates around, you may see what looks like clouds. Those actually are clouds. Mars does have some weather, even though it has a very thin atmosphere. We do get some weather on Mars, and we do get clouds, especially clouds coming off of the peaks of high mountains and volcanoes. All right. What's next? I think that's it, right? Yep, that's it. So I'm going to give it back to Eric here. There you go.
All right. Thanks for that, Gerald. Always inspiring to hear you share all your knowledge and all your cool photos. Well, I think that about wraps up the evening tonight. A couple things. Please visit us at chabotspace.org for updates and for events and support. Click on Join and Give. A couple things coming up next week or for the rest of this month. The launch party as described earlier. So go on our events page and check that out and get updates for that. Next Friday, July 31st, is a talk with NASA scientist Lauren Abbott about the Mars 2020 Perseverance. So you can check out that and get times. Tune in every Friday evening at 8 p.m. for a variety of engaging programming that you can enjoy and participate from home. Also tune in every Saturday evening at 9:30 p.m. for our virtual telescope viewing with our astronomers and with Gerald. You can visit our website, chabotspace.org, for anything else. And do you want to say one last thing?
No.
Oh.
We're going to do some Q&A
Oh, yeah.
after this.
Let's,
I'm sure people have questions.
yeah. If you have any questions, please, you're welcome, Prasanta. Type them in if you have any last questions for Gerald. Give me some lag time. Do you see any coming on your end? Yeah, thank you. We appreciate you tuning in. Oh, here we go. Here they come. Can humans go up to Mars?
Well, the answer is not yet, but we're working on it. Right now, we're still working on trying to get back to the moon. There's plans to return to the moon in about 4 years, but the next stop after the moon will likely be Mars. So probably somewhere in the 2030s, we will definitely be heading up to Mars. Not sure if we're actually going to land on Mars. There's some talk about rather than going to Mars itself, which is quite a challenge to land on Mars and then take off again from Mars. But we might land on one of the moons, Phobos or Deimos. So that's a possibility.
When is the Perseverance launch? The 30th?
Perseverance will launch on the 30th. Launch time is 4:50 in the morning. We are going to have a launch party starting at 4 o'clock in the morning, so please join us for that. But the launch time is at 4:50. If for some reason some minor problem comes up, they have additional launch opportunities every 5 minutes for about a 30-minute period. And if they miss that one, then they have some more launch opportunities the next day and the day after that. So join us next Thursday morning, 4 o'clock in the morning. We'll watch Perseverance launch to Mars.
Looks like you got some fans. Can they see this CJ video anywhere yet?
We are in the process of putting it up on the CJ website. There is a website that we have. And I guess I should send that to Chabot so you have it. It's called cj.lmckeega, LMCKEEGA.org, cj.lmckeega.org. And you can see quite a bit about, not only see the rover in action, but also see a lot of notes and photos of how it was built.
Is Elon Musk planning anything? I think he's planning a lot. But.
Yeah. I don't know that Elon Musk has got anything in the off right now. I know in August, the 2 astronauts that flew on the Crew Dragon to the space station, they're coming back. I believe it's on August 2nd. So that'll be the culmination of that first Crew Dragon mission. And then there'll be another one later on in the fall.
How much does CJ weigh?
CJ is very lightweight. It's only about 25 pounds, so it's pretty easy to pick up and move around.
And how do Curiosity and Perseverance travel over rocks?
Well, both Curiosity and Perseverance have what's called a rocker boogie system. It's 6 wheels that are independently suspended so that they can swivel up and down and swivel left and right and so on, and do it independently. And that way there's less probability of the rover tipping over as it goes over rocks or rough terrain. Also lets it kind of get itself out of difficulty if for some reason it gets into a situation where it's loose dirt or they get something underneath it. The versatility of that rocker boogie system really allows them to do a lot and stay out of trouble as they go over the rough terrain on Mars.
Well, it looks like people are asking for a rover maker workshop. Let's see. Did life ever exist on Mars?
Good question. That's why we're going to Mars. We don't know that life ever existed on Mars, but we do know that the conditions that could support life existed on Mars. In fact, one of the missions, in fact, the primary mission, I think, of the Perseverance mission is to go up and see if they can find evidence of ancient life or even current life on Mars. The rover is going to land in an area called Acidus Planitia, which is near Syrtis Major on Mars. In fact, we've got the Mars model behind us here. Let me turn this a little bit, and I can actually point out where it's going to be landing. This feature right here is called Syrtis Major, and right up in here is the Acidus Planitia region. There's what looks like an ancient river delta, and it looks like there's a lake there, and it's right about in this part right here. And that's where Perseverance is going to land. And the reason they picked that site is because it appears there used to be a lake there and a river flowing into it. So there's a good chance that if there was ever life on Mars, it would probably be in a lake, and so that's where they want to search.
We've got a couple questions from some kids, and then maybe you can pair it with this one. Why is it easier to land on the moons? And then a 6-year-old wants to know what the Mars moons look like.
Well, the Mars moons look like asteroids. In fact, there's a lot of theory that both Phobos and Deimos were actually captured asteroids. And the reason it's easier to land on it's because they have very weak gravity. They're much smaller than Mars. They're way smaller than our moon. They're just the size of asteroids. And so they have very weak gravity. That makes it very easy to land on them and, more importantly, to take off again. If you were to land on Mars, it takes a fair amount of fuel to take off and leave Mars again. So landing on one of the moons would be a lot easier.
Looks like, the launch party is on the 30th at 4 a.m. You can visit our website for updates. What's this one? Why CJ cannot be hexagon?
Why it can't be a hexagon?
Yeah.
I'm not sure what.
Yeah. I'm not sure either.
Yeah.
Because it's not a hexagon, right?
Yeah, it's not a hexagon. Yeah.
How many months would it take to get to Deimos or Phobos?
Well, it takes about between 6 and 8 months to get to Mars. And that depends on the timing of your launch from Earth and which route you want to take to get to Mars. We're actually going to talk a little bit about that in 2 weeks. I'm going to do a presentation a little bit about the orbital mechanics of getting to Mars. So something you want to be sure to tune into here in 2 weeks. But it takes about 6 to 8 weeks to get to Mars. And since the moons are orbiting around Mars, you get to Mars in 6 to 8 months, whether you're going to Mars or going to the moons of Mars.
All right, I think that about does it. Everyone, again, thanks. We appreciate you tuning in to Mars Madness Mishmash or Variety Show. Please help support our institution, our vital role in STEM education and inspiring everyone around. You can go to our chabotspace.org to get updates on events and donate and support us. Have a good weekend. Be safe. Thanks for all the donations tonight. It really means a lot to us. Every amount really counts. Have a good weekend. Stay safe. Be healthy. And, if you can, give someone a hug. All right. Catch you later. Oh. CJ says bye.